Engineering 305, example problem 6.1. A steel shaft is used to transmit a torque from a motor to operating units in a factory. The torque is input at gear B and is removed at gears A, C, D, and E. So we're going to put in the torque here, that 55, and then it comes out. That's going one way, and then all the others are turning the other way. They oppose it, and so this 20 plus a 10 plus a 15 plus a 10, 20, 30, 45, 55, that equals that's going in. So this is my inbound, and these are all out. All right? This actually is an old way of doing things. We had a water wheel, and we took that torque and we put it in there, and then we took that out at various places in the factory with other pulleys and shims. It worked really well. I'm going to clear my board a sec. Hold on. Okay, but this problem is not about what we've been talking about. Is not about what we were learning about, which is we were learning about the shear and the displacement, the stresses and the displacement. This is actually a classic 202 problem that when we did 202, we just didn't do torques this way. So they want, or most people don't do torque. So this is a torque problem instead of a force problem, and we're just being asked to solve the free body diagram. So determine the torque transmitted by the cross sections in the intervals AB, BC, CD, and DE. Essentially, this is a wedding cake problem with 4 layers. A, B, B, C, C, D, and D, E. We've got 5 gears, but it's the places in the middle that are transmitting the torques. And so that's what we have to understand. So I think the easiest way to do that is if we would draw, here's this first gear and this shaft, and then we say, oh yeah, I'm going to cut it right there. The only thing I have acting is this 20 kip. Right? That's it. So the shear stress at that plane is, or the torque, kip inches. I was wondering about that. Kip inches. Now I've got 20,000 inch-pounds is what's the torque acting at that plane. Now let's keep going the other way. Now let's keep going same way. I'm going to cut it again. Oh, I'm going back to my other color though. I'm going back to blue. I've got this one, and then I go here, and I've got this one, which is bigger, and then I keep going on, and I'll draw that. There's my center there. Now, I cut it here, and I've got 20 and 55. Kip, inches, kip, inches, kipping. All right. If I do the sum of that, I'm going to get, and we could pick a sign convention or whatever, but this is now a minus 35 kip inches at that interface. And we keep going. If I draw this one, this one, remember I've got 20. Ooh, getting sloppy. 55, 10. Well, now I've got, at this interface, I've got a minus 25. And I can keep going. And in fact, that's what they did over on the side. They gave us this cute little drawing. I've got 20. Sorry about that. Totally shanked it. Oh, it's back. We did all of these sections. So this one is from A to B. Oh, it's even labeled right there. I didn't see it. Torque A to B. My pen wigged out on me again. Oh, there we go. Torque from A to B. Oh, I can't. Pen. I wonder if my battery's going. I've been using it a lot. Anyway, that's what this chart is those stresses. So you can see our first one was 20, And then we did 20 and 55, and we get a net over here of 35. It got better. And then we've got a 20 and a 55, and I got a net of 25. And then I've got 20 and a 55 and a 10 and a 15. And that makes 30, 45, 55, and it gives me a 10, which ought to be what I pull off of the end. And it is. I pull 10 off the very end. And that's just a free body diagram for what are the forces in each section. And then they ask for something that you maybe haven't done before. Draw a torque diagram. Draw a torque diagram for the shaft. Well, the question is, it would be pretty easy to draw if you knew what it was. And a torque diagram, and we're going to have something like it, and I think you already have done this in 202, is a shear diagram or a moment diagram, where we're going to draw the torque as a function of its distance across the shaft. So starting from let's see it back my eraser. Starting from this end, we're going to work our way across that way, and we're going to say what's the torque in this section, and then what's the torque in this section. And that is really just the accumulation of our answers. So if I were going to start doing it, I had 20 and then I had negative 35, mine would look like this. I might go in red. 20 is 4 bars up. And then when I get to B, I go down to 35, which is going to be 7 bars down. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go, I don't know how many bars is this, 5-ish. And then my next one, I picked up 10, so I had to go to minus 25. Yep, and then I ran another little ways. And then I think I picked up 15. And then I picked up 10. So this is 25, minus 35, minus 25, minus 10. And this is A, B, C, D, E. And that's what their diagram here is. So there's problem 6.1. It really isn't a stress problem or a displacement problem. It's just getting us grounded in the basics. So maybe we ought to do another example problem. Yeah, all right. I'll find one that's appropriate and we'll bang it out. Stay tuned. There's more coming.